So these last two examples are we're going to be verifying and really working with our identities in more of an algebraic manner. The first example says that I want to verify that something is indeed an identity. Remember that when we approach this, we're trying to tackle the more difficult side and turn it into what looks to be the easier side. So I can tell you right now that this term over here is the more difficult side. And so we're going to see if we can rewrite the left-hand side as the right-hand side over here. So anytime I have something that's surrounded, a binomial that I'm squaring, in other words, I am going to think FOIL, right? I'm going to be multiplying this out. That's the same thing as saying the sine x plus cosine x times sine x plus cosine x. So if I do FOIL first, which would be sine squared x times the outer, which is a positive sine x cosine x, plus the inner, which is a positive sine x cosine x, giving me 2 sine x cosine x, and then the last, which is cosine squared x. So all we did was use FOIL to expand that. And now let's see if we can, what we're going to do next. I hope that you recognize a sine squared and a plus cosine squared. I'm going to rewrite those so those are next to each other. That looks like sine squared x plus cosine squared x. And then I'm just going to bring down my 2 sine x cosine x. So when we are simplifying this even further, I can tell you that sine squared x plus cosine squared x is equal to 1 by the Pythagorean identity. And I can tell you that 2 sine x cosine x is our new identity we learned today, which is the sine of 2x. And that's what I was asked to find. I was asked to verify that this is indeed the right-hand side, and there. That one was pretty short, right? Okay, so last, let's look at this one right here. This particular problem is really complex. It's going to really tax how much algebra you remember. So see if you can follow along, and then I'll go back in and write down the reasons for my steps after I'm done lecturing. Now, we are asked in the directions to rewrite cosine 3x in terms of just cosine x. In other words, this has the number 3 next to its x, and I want to rewrite it as a single angle, not, say, a triple angle. Okay? So we're going to start here, and we're going to say, all right, so the cosine of 3x. Well, do you agree? Is it okay to be able to say, I can rewrite the number 3 so it looks like 1 plus 2? Well, that's right. 1 plus 2 is 3. So we're going to use that concept, and we're going to rewrite cosine of 3x so that it looks like the cosine of x plus 2x. Now what that's going to gain me is it's going to allow me to then use my sum identity for cosine, okay, which is the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. Okay, so far we're getting there. So in other words, I took cosine 3x, and I'm now down to this right here, but everything in here, everything in my statement has to be in terms of cosine 1x. That's not the case right here, and that's not the case over here, especially not here because I have this in terms of sine. So let's tackle one thing at a time. These cosine 2x and sine 2x, those are our new identities we learned today. So we're going to rewrite this as the cosine of x times one of the cosine double angle identities. Now we have 3 choices to use here. It is not going to matter one bit which you choose. I happened to choose, when I was originally doing this, to rewrite this using 2 cosine squared x minus 1 as the form of the cosine double angle. Now again, those other two forms, I challenge you to go back and replace this concept with either of those other two forms and you'll come up with the same answer. So we rewrote cosine 2x in this way, minus sine x, and we're going to rewrite sine 2x, again using its double angle identity, to be 2 sine x cosine x. Okay, so now that I have one term times this over here, I can multiply, or I can distribute here. That's going to give me 2 cosine cubed x minus cosine x. Cosine x times this first term. Cosine times cosine squared is cosine cubed. And then cosine x minus 1 is this. Minus. Now, when I multiply sine into this whole thing right here, that's going to give me 2 sine squared x cosine x. Because a sine times a sine is just simply 2 sine squared x. So now that I'm down to this right here, again, let's keep your eye on the prize, right? I'm trying to turn everything in terms of just cosine x. So far, this is good. This term is in terms of cosine x. This thing here, the only odd man out I have is this sine squared guy. Now, anytime you see sine squared x, I don't know, the first thing you probably ought to think is the Pythagorean identity, because that's going to be your best friend for a lot of things. So I'm going to replace sine squared x using the Pythagorean identity. Let's first rewrite this. 2 cosine cubed x minus cosine x minus, now I'm going to do something here. I'm going to take the 2 and bring it down. I'm going to bring the cosine x and bring it to the front. And then I'm going to rewrite sine squared x as 1 minus cosine squared x. Okay? Now I did this, bringing it to the front so that I can take that and distribute it, and it's a little bit easier for me to see. So I'm going to distribute my 2 cosine x and then clean this up. So I get 2 cosine cubed x minus cosine x minus 2 cosine x, and then take this and multiply it in here, and I get plus 2 cosine cubed x. Cosine times cosine squared is cosine cubed. So I have 4 terms here now, and we're going to collect our like terms. I have a cosine cubed and a cosine cubed here, and I have a cosine x and a cosine x there, so those are, you can see from my lines, which are like terms. So I have a total of 4 cosine cubed x minus 3 cosine x. And there we go. I rewrote cosine 3x like this, so that this is now in terms of a single angle and not in terms of what we would maybe consider like a triple angle. Okay? So again, cosine is a little bit different because we have different versions of it that we can use. And when I got here to the double angle for cosine, I had 3 choices to choose. I just happened to pick this one in my notes. But again, I've done it all 3 ways, where either form of cosine 2x I choose, the process is going to be similar. So I would highly encourage you to just take a few minutes and try this process one more time using one of the other forms of cosine, because if you do, your answer should still come out to be this.